webcast looks at Worksheet 2B, where we're talking about motion maps and position versus time graphs. So in number 1, we are given a position versus time graph. And from looking at this graph, I can see that this object begins at position 0, and then it first moves in the positive direction. It pauses for a second, and then it moves back in the negative direction. Let's describe this in words first. And girls, for the sake of time in this video, I have typed my description rather than writing it by hand. So you always want to say where the object begins, and this object begins at position 0 meters at time 0. Then you state 3 things about each part of the trip. First of all, what is the direction that it was moving? Second, what was the speed that it was moving at? And third, how long did it have that type of motion? So you'll see this pattern repeats for each part of the motion. Okay, so first, the object moves in the positive direction at 2 meters per second for 2 seconds. And I can tell that because in the first second, when I've gone over 1 second, the position has moved from 0 to 2. So in that 1 second, it moved 2 meters. That's 2 meters per second. And it had that type of motion until it reached time 2. Then it pauses for 1 second, and I can see the pause because it stays at the same position, 4 meters, from time 2 to time 3. Then it moves in the negative direction. I see a negative slope here, so that means it's moving in the negative direction, and it moves at 1 meter per second for 4 seconds. And I can tell that it's 1 meter per second because as the time goes over 1 second, the position has come down 1 meter. Okay, so we've now described this motion in words. Notice that it takes a lot of words to clearly and unambiguously describe how this object is moving. These graphs, the position versus time graph and the motion map, give us the same information, but we can just look at those and very quickly get a sense of how the object is moving. Okay, but now let's do a motion map. So in the motion map, the axis here is showing me position. And so right now it's labeled with position, and I'll just add a few more. The scale markings. There we go. So it's labeled from 0 to 5 meters. And now I'm going to start putting in the position dots that show where the object is at each second. So at time 0, the object is at position 0. So I put a dot above the 0 meters, and that first dot is for time 0. My next dot will be for time 1 second. And I look over here on the position versus time graph. The position at time 1 second is at 2 meters. At 2 seconds, the object is at position 4 meters. Then, at time 3, it's still at position 4 meters. So the dots stack, right? The position did not change, but time went on, and so I need to keep the dots moving. And then the object starts moving back in the negative direction. So at time 4, it's at position 3. At time 2, it's at position 2. At time, at time 6, it's at position 1, and at time 7, it's at position 0. Now that I've put the position dots in, I'm going to draw in the velocity vectors. They need to point in the direction that the object was moving. And I can see that at the beginning, for the first 2 seconds, the velocity vectors are longer. That's because the object was moving faster in those first 2 seconds. From time 3 seconds to 4 seconds, the object stayed at the same position. The position dots stacked, I had to change levels. So here I went up a level. You could just as well have gone down and that would be okay, but I needed to change level because I don't want those stacked dots to be on top of each other. If they did, I couldn't read how long it stayed at that position. But by counting how many dots stack, I get a sense of how long it stayed at that position 4 meters. And then it starts moving back in the negative direction, and it's moving more slowly. And I can tell that because the velocity vector is shorter. And if you want to, this is not really essential, but I'm going to mark the beginning and the end just so that people don't get confused. Okay, so we have now represented the same type of motion 3 different ways. Let's go look at another one. Let's look at number 2. So in number 2, they have given me a motion map, and now I'm going to create the position versus time graph that corresponds to it. Okay, so in this case, the object begins up here at position 5 meters, and so at time 0, the object is at position 5. The next dot represents time 1 second, 1 second later, and at 1 second later it's at position 4 meters. And I could fill these in if that helps to see what we're looking at. At the next dot it's at position 3 meters. At the next dot it's at position 2 meters. And look, here I have 3 dots stacked on top of each other. When dots stack, that means that the object is staying in one location for a little bit of time. Here it arrived at position 2 meters at time 3 seconds. It's still there at time 4 seconds, and it's still there at time 5 seconds. And that's when it decides to move. So it has paused for 2 seconds. Notice that I have 3 dots stacked up there, but the second is the amount of time between the position dots. Okay, and so at time 6 it moves to position 1, and at time 7 it moves to position 0, and then it stays at position 0 for the next 2 seconds. Then the object begins moving back in the other direction. The arrows are now moving to the right. It's moving in the positive direction. So at time 10 it is at position 2, and at time 11 it is at position 4. So I've put all of the positions at each time, and now to complete my position versus time graph, I can connect these dots. Okay, and then if I wanted to describe this motion in words, then I would say, and remember our pattern, first I say where it begins, and then for each type of motion, each piece of this journey, I want to give 3 pieces of information: the direction of motion, the speed, and how long it does that. Okay, so beginning at position 5 meters at time 0 seconds, the object moves in the negative direction at 1 meter per second for 3 seconds. Then it pauses for 2 seconds. Then it moves in the negative direction at 1 meter per second for 2 seconds. Then it pauses for 2 seconds. Then it moves in the positive direction at 2 meters per second for 2 seconds.